Good morning, everybody. Happy snow day. We have just a little bit to do today, not a whole lot, and then there's just a short assignment, so hopefully it won't take your whole day for you to do my assignment. But here we go. Let's take a look at some review from last week that we were doing. So up here we have a list of some compounds. These are ionic compounds because we have a metal and a nonmetal. And last week we talked about type 1 compounds. Those would be those that have transition or have a cation that only forms one charge. And then we had the type 2 compounds, which are the ones that have a transition metal in them, or tin or lead, that you would have to use a Roman numeral in their name. So we're just got a little practice here. Tomorrow back at school, we will go over your homework that you had for the weekend, and we can answer any questions that you had over that. Okay, so never fear. All right, so let's take a look at this first one. We've got PBBr2. So you would look over at your flow chart here, which is kind of a handy-dandy thing, and figure out whether you need to use a Roman numeral or not. And if you remember, PB was one of those elements that we said that we needed to use a Roman numeral. So we have to figure out what that is. So I'm going to let you look at that for a minute. See if you can figure out what that compound is. We know it's got lead in it and bromine in the form of bromide, and the Roman numeral then should be a 2 for that. And you can ask questions tomorrow in class. I know you can't right now, but we'll take care of those. Now we're going to go to the next one, this AlBr3. Look over at your flow chart, see if you need to use a Roman numeral in the name or not. Might need your periodic table, because I don't expect you to have those elements memorized. And the name of that should be aluminum bromide. Okay, going to this next one here. Take a look. That one should be lead 4 bromide. Okay, moving on to the other ones. Na2S should be sodium sulfide. And we got FeS. It's a little bit harder. Focus on the charge of the sulfur. And looking at that, then you have iron 2 sulfide. Then we go over to the COCl3 compound. And there we do need a Roman numeral, and that is called cobalt 3 chloride. Notice our endings here, IDE on those. And then the last one on this slide, Fe2S3. Again, look at that sulfide. Then look at the combinations of how many sulfur you have, how many iron you have. Figure out what that charge should be on that iron. And the result there is iron 3 sulfide. So I know it's been a couple days, but hopefully those weren't too hard. And if you do have questions, we can answer those on Tuesday. All right, so the lesson for today is covering binary compounds again, but this time we're going to be looking at those with nonmetals, and we call those type 3. So these are our covalent compounds or our molecular compounds. Now, as we work with these, we're only going to name covalent compounds that have 2 nonmetals in them. We are not going to worry about naming those that have more than 2 covalent atoms in the covalent compounds. So here's how this goes. Now this is quite a bit different from the ionic naming, and a lot of people like to confuse the two. Not that they do it on purpose, but it's easy to mix them up. So we've got to make different file folders in our brain to help us keep track of these. So now when we have 2 nonmetals in our compound, then we are going to use what we call prefixes when we name these. And some of you are familiar with this, but you do not use prefixes when we're working with ionic. So that's the difference between the two. Ionic, you do not use prefixes, and the covalent compounds you do. So the first thing you do when you name the compound is you name the first element using the full name from the periodic table. And then you name the second element as if it were an anion. Now it is not an anion, but the name is the same. So in other words, these are going to end in IDE. It's hard to write with a mouse, but there we go. These are going to end with IDE, just like our anions did. Okay, and you'll see what I mean by that in a minute. Then we're going to use something called prefixes. And what the prefixes do is they tell us how many of the atoms of each element are in the compound. And there's some rules and do's and don'ts with that, but we'll look at those as we go through. This is one of the rules, is mono is a prefix, meaning, we all know what mono means. That means one, okay? We are not going to use the prefix mono for the first element. Okay, so whenever we're naming that first element in the compound, we will not use mono. It just will be kind of blank. It's kind of like an understood situation. Okay, now we will use mono for the second element if there's only one, but it is never used on the first element. Now, if you take a look at this table I just brought up here, these are Greek prefixes right here. Okay, so they should look familiar to you, right? Mono, di, tri, definitely. This one here, tetra, is the one that's not quite as familiar to people, but tetra stands for 4. Penta, most people are comfortable with. Hexa is another one that's a little confusing, but the nice thing about hexa is that it stands for 6, and hexa has an X in it, and so does 6. Now, I got the wrong color ink here, but so the idea is 6, hexa, and 6 both have X's in it, so that might be helpful to you. Hepta is 7, octa is 8, and then there are 2 more. And if you look in your textbook, in your chart, you see these 8, but somebody should have written in 2 additional prefixes. One of those is nana. Oh, shoot. Why does that do that? One of them is nana. Here, I'll write it up here. It'll be better. Nana, N-O-N-A. Silly little thing. Okay. Didn't work. Okay, let me do that again. Let's just cross it off. Nana, that equals 9. And then the other one is deca. D-E-C-A. And that stands for 10. But those should both be in your textbook, handwritten in there. Okay, so now what do we do with those things, Mrs. Fairchild? Well, these prefixes are placed in front of the element name to tell how many of each atom is present in the compound. And I think once we start working on it, you'll understand what I'm saying. Okay, so let's take a look. Again, though, remember that this mono prefix, this one up here, the 1, is not used for the first element, but it can be used for the second element if there's only one. Okay, so here are some examples. Using your periodic table, you should be able to figure out the names of the different elements. So this first one, we have carbon in it, and the second element here is chlorine. How many carbon do we have? We have only 1. All right, and again, we are not using the prefix mono on the first element, so this should be carbon. Okay, and then the second element is chlorine, but the rules told us that we're going to add an IDE ending, so this is going to become chloride. And then we have to tell how many of them we have. Well, 4, if you go back to your chart we were just looking at, stands for tetra. So this is actually carbon tetra. And then we put the element name with the IDE ending at the end. Okay, so it's carbon tetrachloride. Sorry, my handwriting is so horrible. All right, then the second one here, let's take a look at that. We have nitrogen and we have oxygen. So we just want to tell everybody how many of each we have present, and we write them in that order. So nitrogen comes first. There's only 1, but we are not using mono for that. So this is nitrogen. And then we have oxygen. How many oxygen do we have? We've got 2. The prefix for 2 is di. And then we write ox, but we're not going to do oxygen. We're going to do oxide. Because remember that second element, excuse me, ends with an IDE ending. Now, you look at this one and see if you can figure out what this one is, okay? IF5. Give you a second to look at that. Okay, so hopefully you realize that that's iodine. And then we have fluorine. We have 5 of them. The prefix for 5 is penta, like pentagon. And then what is that element? It's fluorine, but we're going to add that IDE ending, so it's going to become fluoride. Okay, this should be an E here, E. Okay, so let's do another one. Let's say we had N2O. Okay, now this time, the first element, we have more than one, right? So we know this is nitrogen, so you write nitrogen. But we have more than one, so we have to tell how many we have, and the 2 stands for di. So it's actually dinitrogen. Put an N at the end there. And then the second element is oxygen, and how many do we have? We have 1. So now we got to tell how many that is, and we're going to do mono. So mono can be used on the second element, but not on the first. And then what is that element? That's oxygen, but we're going to write oxide. Okay, now what you'll see here, you've got these 2 O's right here. Well, we have a little rule that takes care of those 2 O's. Whenever we have 2 of the same vowel next to each other, we're going to eliminate one. It doesn't matter which one, because it's a moot point of which one you do. So this actually becomes monoxide instead of monoxide. So the name of this compound is dinitrogen monoxide. That's it. That's all you do with these covalent compounds. Again, we are only going to be working with binary ones, so we're only going to have 2 elements in the ones that we're going to be naming. Okay, and then there are the answers there. So let me pull up my thing here if I can get it. Okay, I guess I'm not going to be able to pull it up. And then the other thing is we talked about this. I'd like to get this off of here, but I can't seem to get my eraser to come up. All right. This is the naming of the element that begins with a vowel. Drop the vowel at the end of the prefix. So that would be something like if we had, let's do this. If we had tetraoxide. Okay, here we've got 2 vowels right next to each other. When we've got 2 vowels right next to each other, if they're not the same, we can keep both of them if we want, call that tetraoxide. And some people get rid of that A and just call it tetroxide. So you'll see it done either way. The one time that we do eliminate, that we always eliminate the double vowel is, again, like I said, that monoxide, that monoxide. If you end up with both of those O's next to each other, we always eliminate one, and that turns into monoxide instead of monoxide. So that was this example here. Okay. All right, so there's a little comic relief for you, very pertinent since it's getting close to Christmas. You guys can read through that if you like. And then here we just have some practice problems. Okay, here's a nice flow chart that is found in your textbook, or you can just use the one on the slideshow here. Binary, remember, means 2 elements. And then this just breaks it apart into the different types. So if you have a metal, then you know it's type 1 or type 2. If you do not have a metal, you know it's type 3. You always use prefixes in naming those. And then if it has a metal in it, then you have to decide, oh, do I need to use a Roman numeral or not? Type 1, you do not use a Roman numeral. Type 2, you do use a Roman numeral. So let's practice a couple here. This is just that same flow chart. So we got CuO. So you have to decide, is it binary? Yes, it is. There's 2 elements. Is there a metal present? Yes, there is. So that means we go down to this side of the flow chart. Then I have to say, does this metal form more than one cation? And remember, that's if it's a transition metal or if it's tin or lead, then it forms more than one cation, and then that means you're going to have to use a Roman numeral. If it does not form more than one charge, then you just name each ion respectively. So this is a transition metal, and we're going to need to find the charge of that. We look at our oxygen. Our oxygen has a charge of 2-. We have 1 of each ion, so I know that copper's charge has to counterbalance at 2-, so it's going to be a 2+. And so that means the name of this compound is copper 2 oxide. That's a horrible 2. And unfortunately, I don't have my eraser. I can't reach there it is, down there. Can't reach my eraser. It went away. Okay. Then the next one. I'm having technical difficulty today. Okay, so then we've got SRO. We've got to decide where this falls. We do have a metal, so we're going down this side of our chart here. We've got to say, does this form more than one charge? Strontium, it's in column 2, so it actually falls into our type 1 category. So the name of this compound is simply strontium oxide. Looking at this second one here, or this third one, excuse me, letter C, it's a binary compound. Then it says, is there a metal present? Well, boron is a semi-metal, but not a metal, so it does not have a metal in it. So we're going over to this side of our flow chart here, type 3. And so we name this according to how many atoms are present, and we use our prefixes. So this particular compound, letter C, would be diboron trioxide. Okay. Now notice here I have 2 vowels next to each other, but both of those are important in this case for helping us know what this prefix is, tri. So we are going to keep both of those vowels there. Okay. All right, then this other one got a metal in it. So we know we're on this side of our flow chart here, on the right side of our flow chart. Titanium's a transition metal. So we have to find the charge based on the chlorine. All right, I have 4 chlorine here. Each chlorine has the charge of a -1 for 4 of those, for a total of a -4. And then the titanium, I only have 1 of those. So what charge must be on the titanium to counterbalance the 4 negative for all those chlorides? It's got to be a +4. So the name of this compound, letter D here, is titanium, Roman numeral 4, chloride. We got a couple more here. Letter E, figure out which side of the flow chart this should go on. OF2, you're going to go down the which side of the flow chart. We should be going over here to the type 3 side. So you have 2 nonmetals. And we're going to use our prefixes again, just like we did in letter C. Okay, the first element we only have 1. There's a rule for that. And we have 2 of the fluorine. So our name should be oxygen difluoride. Oxygen difluoride. And then this one here, take a look at that. There's no metal present. Both of those are nonmetals. Remember, hydrogen's in column 1, but it is not a metal. Okay. So that means we're looking at type 3. So the name of this should be nitrogen trihydride. Nitrogen trihydride. Also known as ammonia. Ammonia, that stinky cleaning fluid that I was talking about. Oh, we do have one more. Okay, so then this one, take a look at which side of the flow chart does that go down? Do we have a metal or do we not have a metal? Okay, you should see that there is a metal present. You can decide, am I going to use a Roman numeral or not? So you got to look at where potassium falls on the periodic table. It's in column 1. So you should be over here on this side, type 1. Okay? The name of this compound should be potassium sulfide. Potassium sulfide. This is not dipotassium monosulfide because this has a metal in it. We are not going to name it with the prefixes. Okay, we're going to use our ionic naming method. Okay, so I think that takes care of the main lesson for today. The other thing I want to do is point out this chart again, the polyatomic ion chart. Period 5 class, I'm a little concerned of whether I reminded you that you needed to start learning these. I think I mentioned it to all the other ones. And since we are not in school today, I am going to push the quiz back to Friday. But you do need to know these polyatomics by Friday. You need to know the ion formula for those, how many of each atom is present, and then you need to know the charges of each of these, okay? And then the names, you need to know the names. You do not need to know the common names. I'm not going to ask you the common names, okay? But all the rest of these, I think there's 22. And what I did is on Canvas, I put a chart. I hope you can read it. I found it online and then I recopied it to be appropriate for the polyatomic ions that we're using. But on Canvas in the modules section in chapter 5, I put a polyatomic ion tree, I think is what I named it. And if you click on that, you'll see all of these polyatomic ions listed there, and I grouped them together based on the charges and then any like similarities they have. There's some of them that have similar formulas, etc. And so I kind of tried to group them together to hopefully make it easier for you in memorizing those polyatomic ions. So that will be on Friday, which I'll move that on the calendar. I think it's still on Thursday. Okay. Alrighty, you guys. Enjoy your day. Your homework. You're like, what do we have to do, Mrs. Fairchild? You are going to work on the worksheet in that packet I gave you on Friday. The worksheet called Naming Molecular Compounds. You're going to do that. I think there's probably 15 or 20, and that is this type 3 that we were doing today with all of this stuff. That's what you're going to be doing on your worksheet. I think there's 20 of them, and that's all you're going to do for today. So you probably get that out and get that done in about 5 minutes. So I hope that you all have a wonderful day, and we look forward to seeing you tomorrow, everybody.